So in this day and age, when we know so much about so many things, why can't we do better with predicting the weather? Well, maybe you've gotten a sense in this chapter about how complicated our atmosphere is. Probably this entire course you've seen how complicated our atmosphere is and can be. And so it's hard to account for every little thing that can happen in the atmosphere in those computer models. So there's also that we don't entirely understand everything there is to know about the atmosphere. So it's hard to come up with that modeling. Another is that the data that's put into the computers for numeric modeling, numeric forecasting, that data has a little bit of uncertainty associated with each piece of data. And I mean, that's just normal. Whenever you measure anything, it's going to be plus or minus something, but that brings consequences. The other thing is, do you remember back earlier in this chapter I mentioned something about interpolation? I said that if you have a point here that you know data and a point here that you know data, and we kind of interpolate and kind of give the computer this information too, because it might be out in the middle of nowhere, but the computer needs that information. Those holes actually where we interpolate sometimes can also send us down the wrong track with regard to forecasting the weather. So here's the old adage, I wish I could be as inaccurate as the weatherman and still keep my job. But we can kind of talk about how successful a weather forecast is in a few different ways. One is we talk about forecast skill, and forecast skill needs to always kind of compare it back to the talent of somebody to make a statement if they were just using that climatological forecasting. So for instance, it's not going out much on a limb, it's not much skill, for example, if you predict that the daily high temperature in Iowa in the middle of December will be colder than 50 degrees Fahrenheit. Are you going to be correct? Yes. Is there much skill in that? No. So another way, or a way to kind of judge how accurate the forecast was, is to kind of use what we say qualitative information. So qualitative versus quantitative. Quantitative information would be where you actually see, like for instance, you say the high was supposed to be 55, and then you honestly see how close the high was to that number. So there's this kind of a subtle difference. Forecast bias, if something is biased, it means it tends to kind of lean towards one side. So if a forecaster or if a group of people who are always forecasting the weather, for instance, if they're always off by anticipating the high temperature will be higher than it usually is, then they need to look at that bias and try to track it down. So now this is probably intuitive too. I mean, we've talked about different types of ranges of forecast, like the very short range forecast that would be within the next 12 hours or so. And this one is going to be more accurate than the next one. For instance, the short range forecasts are between 12 hours and a few days. As you kind of get it down the road with regard to looking ahead, your uncertainty enters and you're not going to be as accurate. Then we have medium range forecasts, which would be a few days up to 2 weeks. Okay. And then we talked most recently about these long range forecasts that are a week or greater. And they do pretty well. Remember we talked about the 3-month forecasts. If you're looking at temperature and precipitation, not bad.